I want to welcome everybody and thank you so much for joining today's webinar, Large Project Execution, A Better Way, co-hosted by ISA and Maverick Technologies. I'm Michaela Cooper with ISA and I'll be hosting today's webinar. But before we get started, I want to review just a few housekeeping items and let you know how you can participate in today's session. First, in regards to the poll questions and question and answer session, we do have 2 poll questions that are within the webinar. When those poll questions pop up, we ask that you enter your answer into the poll feature, which is on the WebEx navigation on the right-hand side of your screen. Also, we do have a Q&A session at the end of the webinar. And to submit your questions, simply type them into the Q&A box on the right-hand side of your screen. We ask that you do not use the chat toolbox for the Q&A session. We want to keep all of our Q&A session questions all in one place, so it would be helpful if you use the Q&A box for those questions. And if we do not get a chance to answer your question, if we run out of time, the presenter's information will be given at the end of this webinar, and feel free to contact them directly. Second, for those of you who just joined, please make sure you're on mute. We want to respect the time that these presenters have put into this webinar, so please remain on mute. If you'd like to see the phone and audio broadcast connection instructions again, please refer to the confirmation email I sent to you today, or if you go to the top left-hand side of your WebEx screen, you will see a tab labeled Event Info, and some of those connection instructions are included there as well. Additionally, once this webinar closes, a survey should pop up in your browser. We ask that you just take a few minutes. It's a really short survey. I think there may be 6 questions to it. It'll take you about 90 seconds to fill out the survey. And just let us know about your experience at today's webinar, if there's anything we can improve on, or what topics you would like to see us present in future webinars. Okay, I believe that takes care of our housekeeping matters. And now I'd like to introduce our presenters. First, we have Lee Swindler. He has a BSEE from South Dakota School of Mines and Technology, has 28 years of experience in the process industry, 21 of those years on the manufacturing side, followed by the last 7 working for engineering service providers. He is a PMI certified project management professional and a TUV certified functional safety engineer. Welcome, Lee. Next, we have Hunter Vegas. He has a BSEE from Tulane University and an MBA from Wake Forest University. He has held engineering, senior engineering, and production management positions in the naval, nuclear, chemical, pharmaceutical, and system integrator industries. He is currently working as a project engineering manager for Wetterlick Mallet. He is a professional engineer in EE and CSE. He has a North Carolina Unlimited Electrical Contractor's License. Hunter is also a co-author of 101 Tips for a Successful Automation Career and is also a frequent contributor to Intech, Control, and numerous other publications. Welcome, Hunter. At this time, I'm going to pass it off to our presenters to go over the agenda and start our webinar.
Hello, everybody. It seems we've got folks from all over the world, even Moscow one popped up. That's I'm amazed that you guys are up this late, probably for you. But anyway, welcome, and I hope you enjoy our webinar. Here's a quick agenda. It's relatively short. We're going to talk about the traditional approach of how generally multi-million-dollar projects are usually run, and some of the issues and problems that you can run into with the typical approach. And then I'll cover the first section. Lee is going to cover maybe a better model or a better way to go about doing that, and then provide some case study information on how that worked out. And finally, we'll finish with some Q&A, and you guys can rattle us with whatever questions you want. So let's get started. And the traditional model is pretty straightforward. About everybody's lived it, I'm sure. You have an owner, he's got the money. Usually, if it's a multi-million-dollar job, he's probably going to engage EPC, an engineer procure, construct engineering firm, and they're going to handle it for him. And of course, they've got different groups. They've handling civil and structural, process design, designing the vessels, the mechanical piping, and all of that. Usually there's another group that's handling electrical, motors, and lighting. And then finally, there's the last group is handling controls and instrumentation. And in fact, we're going to focus on that last box, the controls and instrumentation box. And so let's take a look at that kind of blown up. So we have our owner, we have our EPC, and below the EPC for the control systems, usually, and it varies somewhat obviously by project, but you've got a DCS vendor of some kind, OEM, original manufacturer, so they're providing the distributed control system, and you have third-party suppliers. They may be handling instrumentation, skid packages, you know, that kind of stuff. And so now let's talk a little bit about these groups and some of the issues that you can run into. What we're going to do is we're going to start with the center, the challenges for the EPC. I have an old mentor that said there are no challenges. I mean, there are no problems, only challenges and opportunities. And needless to say, like any other situation, there are challenges and opportunities associated with this. We'll talk about the EPC first. Then we'll slide down and talk about the DCS vendors and some of the issues that you can run into there. Talk about the third-party instrument, skid package vendors. And finally, we'll come back up to the top of the chain, and we'll talk about how that all looks from the owner and some of the problems that he might have with the standard model. And so let's start with the EPC. There are several things that you need to understand about the EPC. And probably the first is that automation is not a core skill. You know, we showed you the breakout of the project. Automation is really generally a very small piece of the much bigger pot. So the EPC is really more focused on where the money is, which is going to be in the civil structural, going to be in the mechanical, all the piping design. And so automation is a pretty small piece of that big puzzle, and so they really don't focus on it almost by definition because they're handling everything else. And their staff is not nearly as big and broad for automation as it would be for the other areas. So they have piles of folks that do the other, but the automation is going to tend to be a much smaller group. If they're working hard, then they're going to be hard-pressed to focus on this particular project, and that can cause issues. They also tend to poorly define the automation requirements for the DCM. For the OEM. So the DCS vendor doesn't get a lot of specifics, and the same for the third-party suppliers. And ideally, from their perspective, if they can throw it over the fence and let the vendors handle the engineering, then their life is good, right? They don't have to spend a lot of money and time doing that, and they just let the vendors and the third-party suppliers take care of it for them. They tend to give, the net result of all this is you usually end up with a minimally acceptable automation system, enough to get it working, which is really what they're focused on, and they're not really looking at the long-term impact of some of the decisions they make. So generally, the EPC is not going to be focused on controls because it is just a small piece of a much bigger puzzle. So now let's go down and talk about the DCS vendor. Now normally you'd say, hey, why is the DCS vendor going to be willing to take up having to design the system for the EPC? Well, the answer is because if you're designing the system, then you get to spec the equipment. And if you're speccing the equipment that you happen to sell, obviously there's at least a very strong incentive to spec nice, expensive equipment, right? Why go cheap when you can go top of the line? And so there is, by definition, pretty much an inherent conflict of interest if the guy that's selling you the equipment is designing it for you. Another issue from the DCS's side is he doesn't understand the process. He doesn't know it. He may or may not have PIDs. He certainly doesn't have an understanding, a deep understanding of what the system needs to do or what the client needs to do. And he doesn't really have an access to the client directly because he has to work with the EPC. And so he can't ask the client, hey, what do you want, or how does this work, or what am I doing here? All he can do is ask the EPC, which tends to give him short answers without a lot of specifics. But the DCS vendor, he needs an exact definition of the hardware bill of materials and the configuration requirements in order to do his job. If he doesn't know the process, then he needs somebody to tell him that. and no one is. And of course, EPC process engineers don't speak DCS configuration talk generally, and so he's asking questions that the EPC may or may not understand, especially if he's got a very small automation staff. And so now I've got the DCS trying to figure it out. And so the vendor is going to do the best he can do and just try to wing it and get it as close as it can be. And obviously that's bound to create issues. And probably the biggest issue for the DCS vendor is that typically a DCS vendor is not so good at integrating equipment that's outside of his family. He's good at what he sells, he knows that, but when you get, if he's brand X and there's brand Y and brand Z that it needs to talk to, like on the skid package or that kind of, you've got communications interfaces you've got to deal with, that's not going to be something he does well. And he's going to definitely struggle with that side of it. So we'll go to the next one. And I actually got a question here. What is the DCS? I'm sorry, that's a distributed control system. The names change every couple of years, but it's the control system. So whether that's a PLC, a program logic controller, or a full-blown distributed control system, or whatever name, three-letter acronym you want to throw with it, that's what a DCS is. So let's go on here and talk about the third-party suppliers. Now, the third-party suppliers are kind of in the same boat as the control system vendor, in that they have an inherent conflict of interest. If you tell me what magneter I should have and I sell a cheap magneter or an expensive magneter, I'm probably going to tell you you need the expensive one. And so obviously not all vendors are that way, but clearly there's a pretty strong incentive to give you the higher end stuff, especially if you don't know exactly the details of the process. And there again, the third-party guys don't. They don't get a lot of specifics, so they don't really know how it's being used, and so they go with the higher-end stuff because they figure they can handle it. Skid vendors who are selling like skid-mounted packages, so maybe a blower or a heater or whatever that kind of comes in as a unit. They honestly just want to sell their standard package to get out. They don't want to modify it. They don't want to put a different control system on it. They really don't care whether or not it talks to the other system. They just want to ship you the typical unit and get their check and walk. And so they don't understand the needs of the process. They don't understand what the owner is wanting. Again, they can't access the owner directly because they have to work with the EPC. And really, they're not concerned with the long-term maintainability or the life cycle cost of the instruments they're providing. They just want to sell it and go on. And so that takes us back to the poor owner at the top who's paying the checks here. The owner, typically in a large project like this, a plant is sized to operate the plant, and they're really not staffed to handle a very large multi-million-dollar project. And so in some cases, of course, they may have corporate help, corporate capital projects team that makes things better, but still you've got a very heavy load being put on the plant folks to not only run their plant, but also answer process questions and give out details and review all kinds of documents, which they typically get at the 11th hour, and the EPC wants them to review the stack of paperwork in 3 seconds or less. And so how do you, they only got so many folks and they're very much understaffed to handle it. The other thing is they can't really talk directly to the vendors or the third-party suppliers of the DCS systems because the EPC generally is the way that they get to them. And so they really can't get a look at exactly, they can't talk to them and they can't say, hey, I want this instead of this. This is our standard transmitter that we use. And so that line of communications may not exist at all. If it exists, it's going to be generally quite limited. And finally, the reality is that the owner's needs conflict pretty much directly with the EPC. The owner's looking for a long-term, maintainable, flexible system. The EPC is looking pretty much at short-term costs because he's responsible for the budget of the project, and he just needs to get it in, get it running, and get out. And so you've got a very different opinion as to what the right decision is. And if the owner doesn't have the bandwidth to beat on the EPC and say, no, 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 I want this and not that, then it tends to just get done and moved on, and you get what you get. And so we end up with the result. Well, you're going to get delays in buying the DCS equipment. The controls guy, because he doesn't know exactly what to buy, so there's a lot of back and forth trying to figure out what you need. It may or may not be what you need. The configuration is usually delayed. It lacks the functionality because the DCS vendor just did the best he could. It may not even remotely match what the owner actually wanted, but given the lack of information, the vendor did the best he could do. Your third-party systems may or may not integrate with the controls. They may not talk at all. They may not even be able to talk. You get startup delays, you get cost overruns, and in the end, and having been a plant guy and lived in the plant, I can absolutely tell you that in the end, when all is said and done and everybody walks away, you end up spending significant money after the fact to make the system usable and maintainable. I have replaced whole control systems on skid packages. I've had to do all kinds of things after the fact to make it right. And those costs are usually hidden. They're not actually seen in the project. They kind of just hit your maintenance budget after the fact. And I believe with that, we will go to our poll questions. So I've got 2 questions here, and this is where you get to chime in. Kind of just curious how y'all execute automation projects very large projects, obviously not small ones. Do you throw it over the fence to an EPC? Do you let the OEM handle it? Do you self-perform? Or do you use a systems integrator or some kind of an automation company to do it for you? And the second question is, if you were building a 5,000-point I/O system, which system would you use? And we're just kind of curious. I got no dog in the race here. Neither of our companies sell these things, but we were just kind of curious as to what kind of systems are out there. And I think at this point we're waiting for questions. And as I recall, Michaela says that it takes a little while for the numbers to come through, but hopefully they should pop up here in a second. Michaela, is it shut down? Are we done? Oh, there's some numbers. All right, interesting. So y'all do use a fair number of systems integrations. That is interesting. EPC, that was actually the number I would have expected. And I won't comment on the DCS's pro or con, but that is interesting information. And I believe at this point, I am going to flip the slide and hand it to Lee. Lee, do your thing.
Thank you, Hunter. Great job setting that up for us. So Hunter talked about, some of the challenges with that traditional model. And this slide depicts a representation of what we would advocate as being a better model for large project execution. And the big difference here is the inclusion of this automation owner's rep. And the idea is that this entity is an expert. Their core business or their core purpose or their core knowledge is automation. So they're an expert in automation. And the way they function in this model is to represent the best interests of the owners. So let's talk a little bit about some of the things that they might do. So first and foremost, as you can tell by the name of the entity, is they would serve as the owner's representative to the various parties and stakeholders involved in this large project with respect to automation, right? It often works well if they are responsible for how automation and instrumentation is shown on the PNIDs. And also if they take over ownership responsibility for the IO list to get that developed, to make sure it's accurate, and that it is complete, right? One of the larger tasks that makes a lot of sense for them to do is to really develop the DCS and automation in general, automation equipment and configuration requirements, and that's a big job, right? The functional specifications, cause and effect diagrams, recipe descriptions, you know, whatever it takes to define what are the configuration requirements, not only for the DCS, but for these other programmable devices that may exist out in the field that also need configuration. So that's a pretty big task. It works well if they are responsible to integrate the DCS and the third-party systems so that the result is an integrated, coherent automation system when you're done. Like this thing comes together like someone, you know, intended it to work as a single unit. There's often specialized automation scope that the EPC may not be capable of handling. These would be more specialized things like maybe some network design, or, you know, maybe some technologies that aren't so common. The automation folks at the EPC are pretty good at handling maybe some of the day-to-day more common design tasks with regards to automation, field wiring, things like that. But when things get specialized, the EPC may not have that skill set available in-house. And it may make sense for this automation owner's rep to take over the design of a particular aspect of the automation system. Hardware FAT makes a lot of sense for that automation owner's rep to participate in that. You know, they develop the equipment requirements, so certainly you would want them to sit in and make sure the equipment met those requirements. And again, serve on behalf of the owner that the best interests of the owner are being looked out for. Same thing with the configuration, factory acceptance test, and site acceptance test. And then along into automation commissioning, developing the commissioning plan for automation, and participating in the execution of commissioning and startup. Again, making sure things met the requirements, that they work together, and that the best interests of the owner are being looked out for. So now I'm going to move on to our case study that really sort of illustrated some of the problems that can occur with the traditional model and how things can be made better with the inclusion of an automations owner's rep. So this was Clariant Corporation. They're a German chemical company. They were building a greenfield polypropylene catalyst plant in Louisville, Kentucky. About a $250,000 project for them. Actually was the largest capital project that they had ever undertaken. So this was definitely a significant facility for this company. And there was a fair amount of technical complexity involved in this project. It was a Siemens PCS7 control system, both the safety system, the distributed control system, and the building automation system, which is that BAS acronym there. Building automation would be like the fire alarms, gas detection, and suppression systems, things like that. About 4,100 I/O, of which 50% was soft I/O. In other words, didn't come in through DCS hardwired I/O cards. It came in this case, mostly via Profibus. This was a S88 batch unit, a pretty complex batch system. One of the things that stood out was the number of Profibus devices. So 301 total Profibus devices, of which, you know, each one required configuration. And that's really a trend I think we're all seeing in the industry is the field devices have more and more intelligence embedded. But to take advantage of that intelligence, they need to be configured in a coherent fashion and integrated in with the rest of the control system. And that was certainly the case here. Of those 301 Profibus devices, 181 of them were electrical devices, so smart motor starters, variable speed drives, smart breakers, and power meters. So a variety of it had to do with the electrical system there. there were 38 package units. These were units built by a manufacturer that either contained their own control system, like a PLC, or they had instrumentation that needed to be hardwired back into the DCS. So each one of these was its own unique, I guess, control system integration challenge. And part of this being a German company, they used a lot of standards that aren't so common in the United States, like it was a complete intrinsic safe I/O system and electrical, used name your signal levels on the discrete signals, and as I mentioned, a lot of Profibus networking and devices. So this is our project. The original execution model, slightly different than the traditional one Hunter showed earlier, in that the client, the owner here, directly contracted the EPC and the OEM. So you know, this was their way of maybe mitigating some of that, some of the challenges with the EPC filtering out what was going to the OEM. They did contract them directly. And then the EPC, as in the traditional model, was responsible for the third-party suppliers as well. So some of the challenges they were experiencing in this particular project, and this was early on in execution phase. There was a continual evolution and a significant amount of errors present in both the PNIDs and the IO list. The automation requirements for the third-party suppliers was really poorly defined. The EPC, as is often the case, used kind of their boilerplate documents, didn't really pay attention to or customize the automation portion of those specs that went out to these third-party suppliers. And as a result, what was being supplied by the third-party suppliers was not going to integrate in with the rest of the control system. There were already, even though it was early in execution, there was already large delays in the schedule, and there were significant cost overruns from the original estimate. So that's kind of what was happening around the EPC side of it. As far as the DCS OEM, the hardware order was on hold. Basically, they did not have enough definition from the EPC to even be able to come up with a bill of material to get the hardware specified and ordered. They were also unable to start configuration. That there was a rather large gap in this case between the EPC's ability to tell the DCS supplier what needed to be configured. So the EPC was really not capable of defining this somewhat complex batch unit, the requirements how to configure it, to the DCS OEM. And in a lot of cases, and in this case as well, the DCS OEMs use offshore low-cost engineering centers. In this case, it was located in India. And those offshore engineering centers really don't deal well with ambiguity. Their culture is such that they like to have things defined and in a language they can understand. And that was not happening in this case. And as a result, the automation was headed for the critical path, which it never should have been in this type of project. Usually your large mechanical equipment and construction is more critical path, and automation only becomes critical path when you're doing your final checkout. So things were not going well. And in this case, the client, Clariant, they were not staffed. I mentioned this was the largest project they had ever done as a company, and it was being built in Louisville where they had existing facilities, but this was obviously a new plant for that facility, and they really didn't have the local resources to be able to do a lot of help here. They were sort of hiring the resources needed for this plant as the project was going on. So they didn't have local folks. They used corporate folks out of Germany, out of where they're headquartered, and unfortunately, those resources were really overwhelmed and overloaded by the demands of this project. So, and this is very common, you know, in projects that Maverick sees is, you know, as large capital projects are undertaken, the owner companies really don't have this excess number of resources that they can deploy to try to mitigate some of the shortcomings of the traditional model. So this is what was changed then, adding the automation owner's rep. You'll notice, first of all, this looks different than what Hunter was showing and what I showed earlier, I guess, as the better model. The reason is there's no one single way to do this, right? Each project is different, and it requires different solutions depending on the situation. So in this case, you know, because the owner had directly contracted both the EPC and the OEM, they also then contracted an automation owner's rep company to help fill those gaps that were present in that original execution model. So you can see where it fit in there. Some of the tasks taken on then by the automation owner's rep, you know, first of all, supplementing those owners' resources as a representative to the EPC, the third-party suppliers, and the DCS OEM. You know, serving as that go-between to make sure everyone's getting the information they need and supplementing, adding to that information where needed, where there were gaps. So serving as that owner's rep to all parties. In this case, took over development of the IO list and ownership of the IO list, and also provided input into the PNIDs, which were owned by the EPC, but provided input into the automation part and instrumentation part of those PNIDs. The automation's owner's rep took over defining the DCS equipment bill of material and then reviewing and providing feedback on what the DCS OEM, you know, came back with as far as a bill of material. Some of the complex automation scope made more sense for the automation owner's rep to develop and to define. Things like I mentioned a lot of the Profibus. So that Profibus network was pretty complex with 301 devices on it. So to come up with the architecture for that, you know, balanced in a way that there wasn't excessive loading. Also, you know, all those programmable devices needed some definition around what sort of configuration, what sort of parameters you're going to read. You know, these smart motor starters literally have hundreds of parameters that you could read back into your automation system, and you don't want to try to read back hundreds of parameters. So to do the parameterization on each device and figure out which parameters were of value and needed and which handles the control system should manipulate in the device is a rather large task when you have that many programmable devices involved. The automation owner's rep also took over integrating the third-party systems to make sure that what they were supplying was going to integrate into this overall control system. Also developing the configuration functional specs. I mentioned that EPC didn't really have the ability to do that in this case. So to come up with functional specs written in basically in a language that the DCS configuration engineers could understand and utilize was a big task here. The automation owner's rep also managed the safety system life cycle for this project, including tasks like performing SIL verification to make sure the design met the intended SIL level that was required by the client, development of the safety requirement specification, and development of the proof test procedures, and then helping to check out to make sure things work the way they were intended. High performance HMI, high performance graphics facilitation. So again, the DCS OEM was responsible for the configuration of the graphics, but to make sure what was specified followed good industry practices, best practices with regards to high performance HMI, the automation owner's rep did that. And that was in the form actually of sketches to make sure that the overall graphics layout and that the level 2 graphics were designed, cleanly using good principles so the operators could be effective using them. And then finally, to create the commissioning plan and to participate in commissioning and execution. Didn't mention factory acceptance testing, site acceptance testing, all that was part of what the automation owner's rep did as well. And some of the more specialized tasks, including what I mentioned before, but also building automation system. That was kind of a specialized system that was really outside the realm of some of the other entities to be able to define. Field instrument linearization was a task the automation owner's rep performed. The control system side of the loop sheet. So in this case, the EPC did the field side of the loop sheets because they did all the wiring design and everything. And then they just sort of left the control system side of the loop sheet blank. And the automation owner's rep then filled in that side of the loop sheet. Rio cabinet layout, putting the optimum number of remote I/O cabinets in the right locations and helping to specify to the DCS OEM what was needed to be supplied there. Cybersecurity assessment. Again, some of the more specialized tasks where the automation owner's rep was more an expert at those tasks and was in the best position to perform those. So what went well with engaging the automation owner's rep in this case? That owner's rep role worked very well to be able to look out for the needs of the owner with these various parties to make sure they were providing what was optimum in this particular case went well. You might think there could be some animosity between the various parties and this automation owner's rep, but that really wasn't the case. And that was sort of addressed by, first of all, the owner setting the expectation with the various parties that, hey, this automation owner's rep entity that we're hiring, they have our authority. You need to listen to them, if you will. And also the automation owner's rep spent time in the EPC's office, spent time in the DCS OEM's office to develop a relationship there and to really understand and have enough face time that they became a respected and valued entity even amongst those other parties. So that was sort of a key part of the arrangement. Design the difficult stuff. I mentioned the tasks that the automation owner's rep took on themselves. One thing comes to mind is that Profibus network. That was pretty complicated. It was a technology that's not so common in the U.S., so having that expertise in-house in the automation owner's rep made them uniquely qualified and well-suited to do some of that more unusual design work. The programmable device configuration, like I mentioned, all these programmable devices in the field, they all need to be set up in a way that they play nice with the rest of the control system. So that was a task that worked well, having the automation owner's rep perform. Being there for commissioning and startup, once they have this background on what's been specified, what the requirements are for these various entities, then to be able to be there during the testing, commissioning, and startup and providing that specialized automation expertise was very valuable. They were able to keep automation off of the critical path, except, of course, during that final automation system commissioning step, and they help to control the cost that the EPC and the DCS OEM, you know, not going with the most expensive DCS solution, if you will, and you know, sort of providing expertise in areas where the other entities might struggle and burn a lot of hours. The automation owner's rep was able to accomplish those tasks more efficiently and more quickly. So, and also the resulting control system incorporated a lot of enhanced functionality that wouldn't have been there had it been left to the EPC and the DCS OEM to provide. So, you know, where does it make sense to spend some additional effort to get, you know, better functionality where the operators can be more effective, like the high-performance HMI, or, you know, better recipe development through, you know, better definition and better testing. So there was certainly a lot of enhanced functionality that wouldn't have been in place otherwise. And as a result, the asset is going to perform better. You know, the control system is the brain of the plant, right? And if the brain's not working well, it really doesn't matter how much you spend on all that other equipment, you're not going to have the best results from the asset than you would if the automation system was optimized. So I think that's my last slide. I'll turn it over to Michaela for the questions.
Great. Thank you both for such an excellent webinar, and I think everybody on the line would agree. So now it's time for the Q&A session. Like I mentioned earlier, you just want to submit those questions into the Q&A box, not the chat box. We want the presenters to be able to see all those questions all in one place. So let's keep them in the Q&A box. While those questions are coming in, I just want to remind everybody about ISA's Process Control and Safety Symposium and Exhibition. That's November 6th through the 9th in Houston, Texas. So save the date. I know that we've got some time on that, but put that on your calendars. That's coming up in November. Okay, let's start off with our first question here. Integrators are used most often on large projects. Is there conflict with them serving as owner's rep?
So I would say that, you know, there could be, obviously, right? Certainly you want to operate things in an ethical manner, but it has to do with how the automation owner's rep is contracted. So, you know, certainly there's a certain amount of just representing the owner that you know, is going to be done just kind of on a time and material basis as to how long it takes. But if there are design tasks that you ask the automation owner's rep to perform, you could also do that as a quoted and bid out function where the owner gets quotes from multiple entities to perform maybe some of those specialized automation tasks that would kind of help keep that automation owner's rep honest. But in general, to perform this, you know, automation's owner's rep task is you're not talking about a lot of resources. It's not a huge team to perform this. It's really, you know, it's representing the owner to these different entities. And so in the realm of the overall cost of the project, you're talking about a very small amount of money.
And I guess I'll ride it on Lee's coattails here and say a couple of things. One, you know, we've been talking about the automated owner's rep, and obviously a systems integrator is an option for that. There are a lot of options for that, though. I mean, you know, if you can, in the best case world, if the plant has got the staff to handle it, I would say the plant should perform this role. But unfortunately, in most cases, especially in a large job, that's not an option. So probably then the next best choice is going to be, if you have like a corporate capital group, they're going to obviously have the company's needs, you know, in mind, and they're generally a very good choice. If you can't do those or you don't have the expertise you need, then you hire it. And usually the systems integrators are really not in that big a conflict of interest because they're not repping any of the equipment. So if a client asks me, hey, spec out an instrument for me, well, I don't sell any of them, and I really don't I don't get kickback on the price of it, so I don't really care. I'm going to pick the best choice for him, looking at his budget, looking at his needs, and going forward. So, I guess to answer your question, I don't see the inherent conflict of interest for the systems integrator that I might see for somebody who's not only specifying it, but then turning around and selling you that same equipment. But Lou's right. I mean, I guess if my desire was to run up a bunch of hours, I could do that, but that would get me one job and never the next. So I'm going to try to be as efficient as I can, so that the next time you have a large job, you're going to want to use me. And so that's kind of at least our perspective, and I'm sure it leads the same way. You're looking at the long-term relationship, not the short-term.
Great, thanks. Moving on to the next question. We would always have our owner's rep on large projects, but would not have this dual management of DCS, OEM, and third parties. What is the split of responsibility?
So that does bring up a good point on defining the responsibilities. So when you engage this automation owner's rep, you certainly want to do a RACI up front, a responsibilities definition exercise to decide exactly who does what. In the case study I showed you, the automation owner's rep was the primary point of contact with the DCS OEM. So the client really only handled the commercial aspects with the DCS OEM, and the automation owner's rep handled all technical aspects. And that seemed to work better than having the EPC try to oversee the DCS OEM, because, again, there was this gap in the EPC not really being able to define things in the way that the DCS OEM wanted to receive it. With the third-party suppliers, it's less clear there. Certainly the EPC had the primary responsibility to define the requirements for these third-party suppliers, but the automation owner's rep got involved, and had they got involved earlier, it would have been very beneficial if the automation owner's rep could have provided input into those EPC specifications on the automation side, and kind of customized those and made those requirements a little more robust, so that the third-party suppliers provided an automation system that was could better integrate with the balance of the plant.
Great, thank you. All right, next question. Any peculiarities in management of multi-EPC projects?
So I don't have personal experience in that, but I don't think it would change the picture all that much. I still think this automation owner's rep would look out for the owner's interest to the multiple EPCs. I know a lot of companies like to split the maybe ISBL and OSBL on a large project to two different EPCs to kind of balance the risk, balance the load. And I would think the automation owner's rep could just as easily perform its role, whether there was one EPC or multiple EPCs.
I would agree.
Okay, next question, this is kind of within the same question from the same individual. What do you think about changes of system integrators' role in automation projects? It seems that vendors pushing them away from the market. What would be a future model of relationship?
So I don't quite understand what's behind the question, but I'll take a stab at it anyway. So I would agree with the statement that vendors in general aren't too excited about having an independent system integrator involved in a project, right? That for some of the reasons Hunter mentioned, they would prefer to be given the authority to make the call on everything that they're supplying, and however, there is that inherent conflict of interest, right? It's in the DCS vendor's best interest to sell the most hardware and licenses that they can, because, hey, they're in business to make money, and those are very high profit items for them. So I can respect their desire to do that. However, is that necessarily in the owner's best interest? So to avoid that conflict of interest with the DCS OEM and instrumentation OEMs, you need someone who's technically savvy enough to call them out when they're not providing something that is necessarily in the best interest of the project in the most cost-effective way.
I'm sorry, gang, I got disconnected. I have no idea what happened. I imagine Lee answered the question. Sorry about that. I was caught midline.
Okay, we can move on.
I'm sure Hunter agreed with my answer.
I'm sure. I guess what I was trying to say before my line dropped out was there are market forces here, and if you're a vendor, you obviously want all of the pie, and so there's always going to be that give or take, and I'll be honest, the systems integrator is trying to get as much of the pie too, right? I mean, everybody's trying to be in business and do, keep their company in play. And as a user, I would say, I mean, look at the scenario and decide what makes sense for you. Some people like, I want one throat to choke. I want one vendor. He's going to do it all. If it goes bad, I can point my finger at him and say, you go fix it. But you've got the inherent conflict of interest there. If you have multiple parties, now I've got to deal with two different folks, and they have the option of pointing fingers at each other. And so now it comes down to relationships and trust and establishing a working relationship and who you know. And so I would say to anybody, doing the work, look at your scenario, understand the drivers on people's behavior, and make the decision that makes best sense for you.
Okay, great. Thank you both. We've got probably a little less than 10 minutes here. We've got a lot of questions, so we're going to try to crank out as much as we can. Next question. We often see incomplete or poor PNIDs and IO lists. It's not always possible to wait. When is it important to push back and delay it until complete versus keep moving on DD?
Oh, that's a good question, and certainly that's often a challenge. And a very hard one to answer, right? So one of the problems with errors in the automation system, so if you have incomplete PNIDs, doesn't have the IO really identified in your IO list, and you move forward, the problem is now you're building, you're designing your wiring system, you're ordering your DCS hardware, you're creating loop sheets, you're doing detailed design activities on a flawed foundation. And as IO is added or deleted or changed, if it's not defined up front and you change it after you're in that detailed design, now something as simple as an IO changes a junction box, it changes a wiring diagram, it changes a loop sheet, it changes your IO list. It could potentially, if there's a lot of them, change what DCS hardware has been ordered. So that's one of the characteristics about automation is when you don't define it up front, those late changes are a much larger magnitude to deal with.
Okay, great. Next question. Is it typical to work directly for the owner on smaller projects? In large projects, we work under GCs and often have electrical subs. We occasionally see requirements for us to have a contractor's license. Is this a GC misunderstanding?
I'm sorry, I'm rereading that one, trying to understand. Lee, do you understand what he's getting at?
Yeah, a little bit. So I understand if you are working under a GC, if you're, you know, a system integrator or something like that, equipment supplier, that is a challenging position to be in, right? Because that general contractor or EPC may not, for the reasons we've talked about, may not be able to give you the direction you need. And so that is a challenging situation to be under a GC and having electrical subs as well. So, and needing a contractor's license is common. It varies from state to state. So that's just kind of a local ordinance specific requirement.
Okay.
Is that how you see it, Hunter?
Yeah, he's asking about if the integrator is working under GC, and I have been in that position, and you're absolutely right. That's a difficult one because now I'm getting pulled in two directions. I have the client, hey, I need this, I need this, I need this, and I have the guy that's paying me money isn't the client, it's the GC. Honestly, that creates another layer of problems, and is a situation probably best avoided if you can. I would much rather be paid by the client and then answer to the client than being paid by the GC but trying to answer to the client, because now I'm being whipsawed between the two. That is a much more difficult situation.
Exactly.
Okay, next question. Is owner's rep a third party company or owner employee?
Yeah, so I could have been clearer on that. It can be either one. It just needs to be an entity who is an expert at automation, who that's their focus in their career, what they do. If the owners have resources they can apply, that's great. They're in a good position to do that. It's just that the current reality in our industry is most owners don't have that surplus of employees that they can apply to it, and so it ends up being an external entity like a systems integrator.
Okay, next question. Are there any metrics or numbers available supporting the benefits of your presented model implementation?
So I can't say that there's metrics because, you know, each project is somewhat unique, and you'd almost have to do like one project with the traditional model and the identical project with the alternate model to compare them. So I'm not going to be able to give you direct metrics, but I will say in the case of like the case study example I presented, you know, looking at the rates that the EPC was charging and the way they were struggling with performing some of the tasks that the automation's owner's rep performed, it was very clear that the automation owner's rep was getting that work done at a much lower cost than the EPC. Now obviously that's not always the case, right? There's certain tasks that the EPC is very good at performing, and it's typically more of, you know, more of the traditional common tasks like wiring design, wiring layout, things like that. I wouldn't advocate that the automation owner's rep try to take over designing the wiring system, because it integrates in with the rest of the plant, the cable tray design and all that. I just don't see that as being a good fit. But when it's a more specialized automation task where, you know, the EPC engineer may only do that on a very, you know, part-time occasional basis, where an automation owner's rep person, that's what they do every day, it's going to get done a lot more efficiently using the automation owner's rep.
Okay, next question. How willing was the owner to accept your model?
So in the case of the case study, this particular owner, I would say, was enlightened. They had one of the key stakeholders was a very strong automation engineer who had been, you know, doing this his whole career, and he could see the shortcomings in the traditional model as they were playing out. And so he didn't need to be sold on the benefits of this. He engaged the automation owner's rep because he knew that was a much better solution than the path they were going down. So there was no convincing required. But I will say in that case study example, the automation owner's rep role started small, just as the owner's rep, and very limited. But then as they got engaged and the owner's representatives became more comfortable and could see the value in engaging an automation expert in some of these tasks, more and more of the scope was given to the automation owner's rep, because it just made sense for them to take that work on versus the other entities.
Okay, next question. Was it considered to incorporate the BMS into the over DCS system? Was it considered to incorporate the BMS into the over DCS system?
So if they are saying BMS, that would be burner management. And this particular plant didn't have, the only burner management systems were part of some of the third-party skid packages, like there was a flare skid, right? So that was handled, in the case of the flare, it was handled by a PLC provided by that third-party skid provider, and that flare PLC was then a Profibus interface back into the main control system. If they're referring to the building automation system, the BAS, which I had called out on this, the BAS was intentionally kept as a separate standalone system, much like burner management systems are. That's kind of an NFPA requirement. And so the BAS, for reasons of wanting independence in the gas detection, fire detection, things like that, was its own independent system with a separate HMI for the operator. However, again, it was interfaced in via Profibus so that the historian, for example, the DCS historian, could capture the building automation system parameters, and so you could take also certain process control steps when a building automation system alarm went off. So I guess that's my guess at answering both possible parts of that question.
Well, thank you both for taking time to answer these questions. Unfortunately, I know we have a lot of questions still left to answer, but we've run out of time. So please take down the presenters' email addresses here. I'll also be sending it in an email later today, and you can reach out to them individually about some of the questions that you have that maybe we weren't able to get to. But I appreciate everybody participating today in this webinar. And like I said, there is a survey that will pop up in your browser at the end of this webinar once it closes out. So just take a minute or two to fill that out so we can know how to improve our webinars and maybe some future recommendations on other topics to present on. And we did record this webinar, so if you missed any portion of it, or if you want to share the recording with your colleagues, anything like that, the recording will be sent to you later on today for your viewing pleasure. This concludes the Large Project Execution a Better Way webinar. Thank you for joining us, and we hope to see you in one of our future webinars.